Hey, how we doing today? Another Calculus with Keller video lesson. Today we're looking at section P.5, another prerequisite to taking our calculus and our trig course. We're looking at linear equations. Specifically, we're looking at graphing linear equations, writing linear equations, slope-intercept form, all those type of ideas. So let's start looking at some of the ideas that you need to be familiar with, some prior knowledge, if you will. First one, slope. We know there's lots of different ways to write slope. Rise over run. It's the change in our y values divided by the change in our x values. You know, the difference in vertical divided by the difference in horizontal. We know it's the m in our y equals mx plus b. All right, that's our slope. And then we know that our slope formula, if I ask you to find the slope of a line, it's y minus y over x minus x. As with anything, always remember, please be consistent when you put those into your slope formula. Okay, so hopefully that rings a bell for you. You remember how to do slope, that type of thing. Hopefully you also remember how to sketch graphs, how to sketch lines. We're going to really primarily deal with slope-intercept form in this class. So if I was to give you an equation like y equals 3/2 x minus 4, could you graph it? Okay. And remember, feel free to always pause this and try things on your own before I do it. All right. It's the best way to really see if you understand it is to do it that way as opposed to just watching me. So if I have this, I'm going to go down 4 first. That's my y-intercept, down 1, 2, 3, 4. And then from there, I'm going to go up 3 and over 2. I could continue to keep going up 3 and over 2 as long as I want, and that should form the line that I'm trying to graph. I sure hope that's relatively easy for you. I know you've done a lot of that. What I worry about sometimes are special cases, when there isn't an x and a y. Like in this case, x equals 7. You know, is that a vertical line going through 7, or is that a horizontal line going through 7? Do you remember which one's which and how to figure that out? For me, what I do, if I can't remember, I just go ahead and write some points down where my x coordinate is always 7, and then I plot those. You know, 7, 0, 7, 1, 7, 2. Those are pretty easy to graph, and the moment that you graph those points, it's pretty easy to see that that's a vertical line going through 7. So any line that has x equals something in it, that's a vertical line. And so it's pretty straightforward to understand that any line where there's only a y in it, that's going to be a horizontal line going through that number. All right? So special cases, watch out for them. Again, sometimes we forget that, and there isn't a lot of ways that you can check outside of graphing points like I did to remember them. Start moving into some example problems now. Let's start with application. Like what is this, you know, how do you use slope, or when will I see slope in the real world, those type of things. But we'll hold off on that actually. I'm getting ahead of myself a little bit here. How about writing equations of lines? Okay, so if we're going to write the equation of lines, and I give you some information like this. So let's say I give you a point, 2, 4, and 4, 10. Okay, so there's a line that goes through those 2 points, and I want you to write the equation of that. What is it that you really need to write the equation of a line? Hopefully you realize that the 2 things you need are slope and y-intercept. So every single problem I give you where I'm asking you to write the equation of a line, your job is to find those 2 things. So if I'm looking for slope of this line, I'm going to obviously use my slope formula. So y minus y, in this case I do 10 minus 4, over 4 minus 2, my x minus x. Remember again, I keep saying it, you're gonna hear me keep saying it over and over and keep writing it. Be consistent. Whatever order you put those in, make sure you do it the same each way. So I work that out, divide it out, I get a slope of 3. That's the slope of my line. Now, when I want to put this in the slope-intercept form, remember slope-intercept form is y equals mx plus b. So if I take my slope and I take either of my 2 points that I originally was given, I have an x, I have a y, and I have an m. I'm sorry, I have an m. I wrote that down incorrectly. That's not a b, that's an m. Alright, and so, excuse me, as I plug them in right now, 4 equals 3 times 2 plus b, and I can solve that now for b. 4 equals 6 plus b, b equals -2. Now I have my slope. Now I have my y-intercept. I can go ahead and write my answer now. Y equals 3x minus 2. Feel free to go back through and watch this more than once if you need to refresh your memory a little bit better. Now, you may have also learned at some point something called point-slope form. I will not teach it, but I'll show you it in case you like this way. Point-slope form looks like this. Y minus y sub 1 equals m times x minus x sub 1. And what you're going to do is you're going to put in your x and your y and your slope, and you're going to solve this. And when you solve it, you'll actually have the equation. For me, I just don't enjoy this way very much, but if you like this way, you can use it anytime you want. I mentioned earlier we're going to do some applications, so let's just look at a simple application. This isn't a difficult problem, but this is really slope in the real world. And so let's say we're talking about the idea of plate tectonics. And what plate tectonics is just the study of how the plates on the surface of the Earth, how they move and bump up against each other and pull apart from each other and so on and so forth. Okay? So you're a scientist and you're studying the North American plate. So that's a plate that obviously covers the North American continent. And as a scientist, you're observing and you're recording how much that is moving in a particular direction over a certain amount of time. Okay? And the information I'm going to tell you is that you've recorded that this plate has moved 240 centimeters over the last 140 years. A very simple application would just be, what is the average rate that the North American plate has moved during that time? And so how would you go about doing that? And hopefully, as you're thinking about it, I know you may be writing the problem down now, or whatever, but as you're thinking about that, hopefully what comes to you is that you're going to take that that change in your one variable, in this case the distance, and divide it by the change in your other variable, which is time, or a number of years. Alright, and so that's just going to be 240 divided by 140. And really, rate of change, remember, is just slope. So if I was to plot those, I could plot the location of the plate for a certain year, and as I plot those points, they should be relatively in a straight line if it's a linear relationship. All right? And as we divide it out, we can see what that change is from year to year to year, and the average change when we take this is going to be a decimal answer. We'll round it right around to what, about 1.7. And we want to make sure that we label that answer as well. So that's 1.7 centimeters per year. Okay? So you might see some problems like this in your homework and on your quiz, applications of slope. Just a couple more errors to kind of tie up here before we finish today. One of them would just be the difference between what we normally use, slope-intercept form, and what is also out there in terms of equations of lines, and that would be standard form. As we've already mentioned a number of times, slope-intercept form is y equals mx plus b. We use it because of its ease of graphing. We can look at a y-intercept and a slope and graph it really easily. Standard form is ax plus by equals c. I don't use this very often unless it specifically comes in that form, and then it's pretty easy to graph as well. But again, just a review, make sure that we're good with this. I don't want to take anything for granted and find out down the road that you know how to graph these. So I went down 1 for my y-intercept and then up 4 over 1. Remember, slope is always a fraction. So if it's written as a whole number, put it over 1. Now if we write it like this in standard form, 3x plus 4y equals 12, you might be familiar with the cover-up method, where I just isolate one variable at a time and just pretend the other one isn't there. And so if I covered up 4y right now, I'd have 3x equals 12. And that would give me x equals 4. If I cover up to 3x, I'd have 4y equals 12 and y equals 3. Those two answers right there, the 4 and the 3, those are actually the intercepts of the equation. The 4 is the x-intercept, or where it crosses the x-axis, and the 3 is the y-intercept, which we know is where it crosses the y-axis. And that's really easy to graph. So if it comes in standard form, and you have to graph it, that's all you have to do, you might want to think about doing that. But you don't have to. Okay, last idea we're going to talk about today is the relationship between parallel and perpendicular lines and their slopes. You might remember from Algebra 1 or Geometry that if you have two parallel lines, that they always have equal slopes. So in my picture, if my top line has a slope of positive 3, then so would the bottom line. Okay, so equal slopes, that's kind of an important idea. And then remember that if we have perpendicular lines, obviously those lines are not equal, and they're going in different directions, so one has to be positive, one has to be negative. But even more than that, those lines' slopes are opposite reciprocals. Opposite reciprocals. What's that mean? It means if we write a fraction, the slope of one has a slope that is the same as the other if you flipped it upside down, like 7/3 and negative 3/7, because they're opposite as well. 1/2 and negative 2/1, or negative 4/9 and 9/4. Now, what I also like you to understand, besides just being opposite reciprocals, is that you can also determine if lines are perpendicular if you take those slopes right now and you multiply them. And what I mean by that is, if I took 7/3 and multiplied it by negative 3/7, I'd get negative 21/21. If I took 1/2 and multiplied it by negative 2/1, I have negative 2/2. And then down here I have negative 36/36. In each of those cases, the answer is negative 1. So that's another way you can think about perpendicular lines. Now, how will we use this? How will we use parallel and perpendicular lines in the problems in this class? What I'll do is I'll include that information in a problem like this. I'll tell you that a line contains a certain point. And we had problems like this back in geometry class, so this should not sound completely brand new. But a line contains the point 7, negative 2. And I also will tell you that it's parallel to the line, well, let's see here, how about y equals negative 3x plus 7. And I want you to write the equation of our new line now. So again, let's go back to what we said earlier in our video. What's the two things that you need for your new line? You need slope and you need y-intercept. Again, feel free to stop this and find those before I do it for you. So how will I find slope? Well, I've told you that the slope of that line is negative 3, and our line is parallel to that, so you already know the answer. The slope is negative 3. How will I find the y-intercept? Well, I've given you m. You've got an x as 7, and you know your y is negative 2, so plug them in. Negative 2 equals negative 3 times 7 plus b. Work all that out, and you get b equals 19. There's your equation. Y equals negative 3x plus 19. Hopefully you remember that a little bit from prior years. Got one more example of this. Just kind of switching up the information a little bit, make you think a little here. So what if I tell you that a line's x-intercept, so the x-intercept of the line is at 6. And we know that the line itself is perpendicular. Remember our perpendicular symbol. It's perpendicular to the line. Y equals I'll go positive 4/3 x minus 7. Write our equation. So again, hey, stop this, pause it, see if you can figure it out. Again, first thing is what? Find your slope. So the slope of the other line is 4/3. Opposite reciprocal to that. negative 3 over 4. That's going to be the slope of our line now, negative 3 over 4. X-intercept is 6. So think about what's that mean. That means that our line crosses the graph on the x-axis at 6. So I've really just given you a point. The point is what? 6, 0. Now there you go. You got your x, you got your y, you got your m. Go ahead and plug those in. 0 equals negative 3/4 times 6 plus b. We're going to solve that right now, so we know 0 equals negative 18/4, which is the same thing as negative 9/2. Same thing as negative 4.5, however you want to write this. Solve that for b. You can leave it as a decimal answer if you like, or you can leave it in a fraction. If you leave it in a fraction, try to reduce it. Alright, 9 over 2. Put it all together right now. Y equals negative 3/4 x plus 9/2. That's the equation of our line that goes through that point and is perpendicular to that line. Alright, here's again the problems that we're going to do tomorrow in class. If you'd like to get a little head start on them or start looking a little bit of sneak peek at what you're going to see, it's on page 58, those problems there. If you have questions, be ready to ask that. Be ready to use that time to get the practice that you need. Thanks, we'll see you next time.